Hey everyone, welcome to the session. So myself Gathin from ZeroG, and I'm super excited to be here to just give you a quick brief introduction about what ZeroG is and how you can build Onchain AI dApps with ZeroG Storage and Compute Network. So before we jump into what ZeroG offers, like what is the issue that you currently face with Closed AI? Closed AI currently acts as a big black box with like the agents, model, alignment, data, and compute, and you aren't able to get much awareness about like what is the being data that is being used for training, like how is the alignment that is being used, like what are the agents, how are the agents are being deployed, the inferencing, like which are the server providers that are used. So this is a big thing without like trustlessness aspect, and also there is like no much clarity on the consensus that is being used. But when it comes to decentralized AI, you will be able to completely decentralize the stack of you from uploading your custom data, like using them for training, using like the data and labeling, to having like verifiable inferencing. So you will be able to completely decentralize this whole stack with using 0G's chain. So just giving you now a quick introduction about what 0G is. So 0G is the largest layer 1 chain and dedicated for like on-chain AI, with powered by the decentralized AI operating system, which provides like a complete infrastructure to build AI powered applications on chain. So our stack comprises of these different layers. So we do have like there are like four core pillars. So we do have like a layer 1 EVM compatible chain, on top of which we have the storage network running, which is like much faster and much cheaper than the existing storage providers, whether it may be decentralized or it can be much other centralized providers. So this is what offers and provides a platform for you to upload the huge AI models and all the training data that is need to be used for training it on chain. Next comes the data availability layer, which is like infinitely scalable, and it has like high speed data availability to provide support for like the verifiable AI workloads. So that brings in like a good off-chain storage for your large-scale data blurbs, and also like it gives you like an off-chain storage, which you could use it for later verifiability purposes when it comes to like verifying how the data is being trained, or like how the data was used before the model was trained. So next comes the compute network. Here you will be able to get verifiable inferencing. For example, we use TEML to verify the data which the model gives as output. So basically the TEML, for example, you just given the input to your compute network, and the compute network process it with the models that are in it, and the final output is being processed in a trustless execution environment, and that is given as a verified output to the user. So on top of which we have the alignment nodes. Think of it in a future scale where like a lot of your like service supply chain market supply chain is completely run on chain, and you need some control over your data, and like whether like the 0G nodes, whether it can be chain or the storage or like the compute is performing correctly. So we did a node sale with like, which is called as alignment nodes, which gives the power to the users. If they can just slash the nodes if they find some malicious activity in it, and that gives the power of decentralization in the hands of users. On top of that, we have the service marketplace, which acts as a decentralized hub for AI models, agents, and services. And this acts like in the future, we'll be adding like RAG support. We have the fine tuning available, and also we will be able to get different GPU providers for you to upload your own models as providers on top of 0G's inferencing. Just a quick brief about what 0G chain is. 0G chain is advanced. It is like a modular layer 1, which is EVM compatible. So this architecture provides flexibility, scalability, and a good innovation in terms of like how this whole transaction execution take place. And we have separated the consensus layer and the execution layer. So consensus layer is where the network agreement and the finality and the block protection takes place, and the execution layer is where the state of the transactions, the VMs, the smart contracts are deployed, and the logs are being stored. So we have separated these both, so you can scale them individually, and there will be much more better throughput in terms of like interaction between these layers. And this is like pretty like this is was what was available for the testnet, and currently we have launched our mainnet like 4 days ago, and you are expecting around like 11,000 plus TPS, and like like 500 milliseconds finality, and the consistent throughput as well. Moving on to ZeroG Storage. So this, what is the issues with the traditional cloud storage? It is fast but expensive, and you need to be logged into to the provider. For example, you are using AWS. But moving on to decentralized options, we have like IPFS, which is comparatively slow. Filecoin has like much more limited architecture, and Arweave is like much more better, but it's highly expensive. Whereas ZeroG Storage, we set a benchmark by providing 95% much lower cost, instant retrieval rates, and we have the support for both structured and unstructured data. And most importantly, we will be able to handle the workload that you need for uploading large scale AI models. The technical architecture behind this enablement for the ZeroG storage is like, we do have two different parts. One is the data publishing lane, the other is the data storage lane. So the data publishing lane is where, so I'll just come with data storage lane. So basically the data that you want to upload to ZeroG's network is split into multiple smaller chunks, which is then split up and sent through the ZeroG storage network. And this data chunks are randomized in terms of storage using verifiable random function, and simultaneously, so as the different storage node receives the data chunks, it will sign the transaction on the data that is uploaded, and it will send it back to the ZeroG smart contract, and that a Merkle tree is created which gives you the complete structure of data. So if the data is stored in number 4, number 7 and number 10 of the storage nodes, the Merkle tree gives you a clear clarity on how this data must be aggregated to get the final total throughput, final whole data when the user wants to retrieve it. So this is completely verified by ZeroG's consensus. So basically the erasure coding and the distribution among storage networks takes place on one side, and simultaneously we have the smart contract creation and the Merkle tree with the Merkle proof of different data chunks uploaded to the ZeroG's contract, which is then signed and approved by the ZeroG's consensus. Then moving on to ZeroG's data availability layer, we have what is the issues that we face with the existing data availability layers that brought in a requirement for ZeroG to bring this up as well to the stack to enable it for like the complete on-chain AI. So the limited horizontal scalability. So many system needs all the data to be sent to the network node simultaneously. So there is no like parallelization of data, which creates like bottlenecks, and it limits the speed, and the slowest node will not be able to cope up with what the fastest node achieves on. And most of the data availability layers lack the usage of built-in storage. They either have like a different third-party storage that they use, and it brings in connectivity issues, throughput, there is like latency impact. You need to have like additional cost if you are using a third-party provider as well. Moving on, they have like weaker securities, whereas in ZeroG we use Ethereum security standard, but a few other competitors have their own security mechanisms, which does not is not as robust as Ethereum. Then there is like some like kind of like AgenD have like insufficient randomizations, so there is a lack of randomization for data committees, which potentially allowing collisions among different malicious node in the network. So this is the architecture diagram which I explained earlier in terms of like the data storage lane, and in terms of like the data route and the data route and the commitment that is like adding in new data to the network. What are the different use cases when it comes to ZeroG's DA? It is similar to what other DA does. Like you can use it for like layer 1s and layer 2s. You could use for sharded sequencers, bridges, RAS, DeFi, on-chain gaming, and data markets. But we specify exclusively for AI and machine learning. So this is suitable for you to upload vast data sets which can be stored on chain, and it can be accessed for utilizing for like AI dapps which deployed on ZeroG chain, or you could deploy elsewhere and you can just utilize ZeroG's DA since we are a modular architecture. The last part of the pillar of ZeroG's network is the ZeroG's compute network. So this brings this kind of like cream on top of the cookie. So we have all the necessary infrastructure that is needed for you to upload AI models, train them on chain, like provide necessary storage for it. But then now what we need is like a final endpoint in which users will be able to utilize the models that are deployed on 0G's chain. So that comes into the 0G's compute network. The existing inabilities of the other networks when it comes to like computation providers is that they are high cost. They have like complex setup because you need like to configure like cloud GPUs and you are locked into the vendors. But with 0G's compute, this is a decentralized framework which will offer AI computing capabilities to the community as part of like the DAI operating system. So this is a brief architecture on how it works. Think of it like there is a meme generating model. So basically there are like multiple models and each model has multiple inferencing. So basically the user needs to just deposit token directly to the 0G's contract and he will be able to use any of the different model providers and he will be able to select the inferencing that he needs to use. It's not like specific to like what ChatGPT offers that you need to definitely pay $20 to get this throughput. There are like different, for example, one person has fine-tuned it so accurately that you get the specific thing, so he charges the inferencing a bit higher, and the other one just have like a generic fine-tuning over the meme generating model, so he charges a bit lower charge. So there is a flexibility for you to choose the cost, the requirements that you need for different types of inferencing on top of the AI models. So with that, the user will be able to interact with the inferencing, and when he interacts and gives in the inputs to the model, all the data that is being processed happens in a trusted execution environment. So for example, you ask a centralized AI model provider and you ask 0G's compute network, the output that, for example, you're asking like a panda image, the image that you get out of the centralized provider gives you with a Nike logo, for example, and with 0G you just get an accurate data. That implies that that data is being tampered. For example, they would have got billions of dollars from any centralized organization providers to just pay for having that. You can just think of it like ads. If you ask like which is the best shoe in ChatGPT, if you want the result to show up to this particular X brand, you could just pay up ChatGPT like a centralized provider. But whereas in 0G, it completely relies on the model data. There is no tampering because it happens in the trustless execution environment. And the final ZK proof of this complete transaction is stored on chain in the smart contracts. So for the AI users, this is the workflow. Like they deposit funds, they request the user service, and they get the result from the best available GPU, and the automatic payment of the necessary inferencing usage happens. But for the GPU owners, it will be like for you to register your own GPU hardware, determine the price for the computing power, and the people who wants to utilize your own GPU can use it for their own models. And just giving a quick conclusion, I know we are like almost on time. So we have this 0G's builder hub. In this, we have all the resources that you need to get started building on top of 0G. And just to give a quick context, we are facing a slight downtime in our testnet right now. So we encourage you to deploy with local testing, like you can use hard hat foundry and you can ganache for testing. And we provide necessary mainnet tokens for you to deploy and test things out. So also like we are encouraging people to build in this hackathon for like on-chain dev tooling. So here we have all the toolings, SDKs, documentations, tutorials. We have like a showcase of all the community projects which previously built on 0G. And for this hackathon, sorry, just give me a second. And for this hackathon, we are offering like a $10,000 bounty, and we are encouraging the builders to build what an early ecosystem or like a layer one chain needs. And currently, we are asking them to use our partner inferencing providers, and later they can migrate to ones like when 0G launches its compute on 0G mainnet. So we did our mainnet launch on 22nd, just 4 days since our mainnet NTG, and we are looking forward to see what builders are planning to build in terms of like dev toolings, explorers, analytic platforms, like DeFi protocols, like meme coin launchpads, NFT marketplaces, and so on. So if you want to like learn more about 0G, here is a link tree for 0G. And if you have anything that you want to ask or connect, that is my Telegram. And you can find me at the 0G's booth. And if you have any questions or if you want to just come say over hi, if you have any doubts, just please come over. And thank you for being a wonderful audience.